Okay guys, welcome to our video on special right triangles. I'm going to go, just over a couple things about what these right triangles are and what properties that they have. So, let's start. First thing we're going to do is we're going to draw a square. Okay, we're going to pretend that's a perfect square. And you know that if you have a square, you've got 4 right angles. You also know that this side and this side, all 4 sides are congruent. Okay, you know that. So now, if you take any square and you draw the diagonal, okay, you've done 2 things. The one thing is you've made 2 isosceles. Oh, I might have misspelled that, but for right now, I'm going to have to not worry about it. You've made 2 isosceles right triangles, and you've also split your right angles of those triangles in half. So if you split this one is now 45 degrees, and this one is 45 degrees. Okay, so basically what you've created, you have created an isosceles right triangle. And like I said, that one's 45, and that one's 45. Okay, so that is our first special right triangle. It is called the 45, 45, 90 triangle. Because it has a 45-degree angle, a 90-degree angle, and another 45-degree angle. Okay, so let's say here's our isosceles triangle. Okay, isosceles means right angle, means that these 2 sides are congruent. Alright, so if I give you this side length, the side length is 3, you know that this side length is 3. And we want to solve for the hypotenuse. Okay, so use the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, so you have 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. Then 18 equals c squared. Okay, and then to solve for c squared, or for c, we take the square root of both sides. So we get c is equal to the square root of 18, which is the same thing as the square root of 9 times the square root of 2. And we know that the square root of 9 is 3. Okay, so this is equal to 3 times the square root of 2. Alright, so let's look at this now. What do you see? You see a side length of 3 and a side length of 3, and the hypotenuse is the side length of 3 times the square root of 2. Okay, let's try another one and see what we come up with. Alright, so here is our triangle. 90 degrees. These are congruent. So let's say this one is 6, this one is 6. We want to see what that one is equal to. So we do a squared plus b squared equals c squared. So we know that's 6 squared plus 6 squared equals c squared. 36 plus 36 equals c squared. 36 plus 36 is 72 equals c squared. Alright, so now we're taking the square root of both sides. So c is equal to the square root of 72. And the square root of 72 is also the square root of 36 times the square root of 2. Square root of 36 is 6. So 6 times the square root of 2 equals c. So this equals 6 times the square root of 2. Alright, so let's look at this. We've got side length of 6, side length of 6. So the hypotenuse is equal to the side length times the square root of 2. So that brings us to our 45, 45, 90 right triangle formula / theorem. Right, so we have 45. So for 45, 45, 90 triangles, okay, that means that for any isosceles right triangle, this is a 90 degree, 45, 45. Okay, these are the same. Okay, so your legs are x, and your hypotenuse is equal to x times the square root of 2. X times the square root of 2. Always. It doesn't matter what they are. So if I say that the leg equals 3, then the hypotenuse is 3 times the square root of 2. If I say that the leg is 19.6, the hypotenuse is equal to 19.6. And I ran out of space, so let's back up. 19.6 times the square root of 2. Okay, so this is what you need to be concerned with, is remembering this, and then also being able to draw this picture. Okay? Alright, so now let's turn around and talk about the other special right triangle. And this right triangle is called a 30, 60, 90 triangle. Alright, so first thing we start off with is we start off with an equilateral triangle. So here's my equilateral triangle. Alright, so if we have an equilateral triangle, you know that this side is congruent to that side, is congruent to that side. Okay, we know that. Alright. So we also know that the angles have to be equal to 60. Okay, so 60, 60, 60, congruent, congruent, congruent. Every equilateral triangle is like that. So if we have, I'm going to draw another equilateral triangle here. Okay, remember when we talked about lines of concurrency and altitudes and median bisectors and all that stuff. If I draw an altitude from this top vertex and I go straight down, what have I done? I've created two segments that are congruent to each other, and I've also split this angle right here in half. So if it was 60, then that means that this one right here is now 30. This one is still 60, and of course this one is a right angle. So if I take an equilateral triangle and I use the altitude, I've now created two 30, 60, 90 triangles. Okay, so if we look at this triangle, we've split this in half. So if I say that this side right here is 2, we know that this side is also 2, but what can we say about that side? Well, we know that this side is the same length as this side right here, so this one has to be 4. Okay? Alright, so stick with me. Let's change pages here. Alright, so here is my triangle. Alright, so I'm going to go ahead and do this. I'm going to draw the rest of the equilateral triangle just so that you can see it, even though we're only dealing with this. Okay, so this one is 60, this one's 30. Okay, if this one is, let's see, 2, or we just did 2, sorry. If this one is 4, we know that this side has to be 8, because this side is equal to the length of the entire isosceles triangle, entire equilateral triangle. So if we had to come up with a formula to find the hypotenuse of a 30, 60, 90 triangle, so here's a triangle again. Okay, and then again we'll draw out the rest of the triangle so you can see it. Okay, if this one is x, then what does this one have to be? This one has to be 2 times x. Okay, so for any 30, 60, 90 triangle, okay, the short leg is equal to x, and the long leg is equal to 2x. So for a 30, 60, 90 triangle, the short leg is equal to x, and the hypotenuse is equal to 2x. Okay, so remember that. Now we're going to talk about finding the long leg, finding this. Okay, all right, so start with our triangle. So here's my 30, 60, 90 triangle. All right, and you also can remember where the angles are because your short leg is always going to be opposite your large angle. I'm sorry, small angle. So let's do this. Let's say if this is 2, going by what we said before, we know that if this side is 2, this side is 4, okay? And we want to know what this side is, okay, which is the long leg. So let's use the Pythagorean theorem. So we know that a squared plus b squared equals c squared. So 2 squared plus x squared equals 4 squared. So 4 plus x squared equals 16. You're going to subtract 4, and you end up with x squared equals 12. And then you're going to take the square root of both sides. So this is x equals the square root of 12. And then the square root of 12 can be written as the square root of 4 times the square root of 3, which equals 2 times the square root of 3. All right, so we've got 2 times the square root of 3. All right, so let's look at what we have here. We've got x, right, there's x, is equal to 2. To get to 4, we did 2x. And to get this one, we did x times the square root of 3. You see that? So there's your x, and then you multiplied it by 2 to get there. All right, so let's do another one to see if it works. Okay, so here is my triangle. Right, it's a 30, 60, 90, so 60, 30. All right, so let's say that this one is 6. Okay, so we already know that if this one is 6, this one has to be 12. And we want to know what this one is. Okay, let's test to see if we get the same thing. So we get 6 squared plus x squared, because we don't know what it is, equals 12 squared. So 6 squared is 36 plus x squared equals 144. So minus 36 is x squared equals 108. Did I do that right? Yes. Okay. And then that means that we take the square root of both sides. X is equal to the square root of 108. You can also write that as x is equal to the square root of 16. Or sorry. Did that wrong? The square root of 36 times the square root of 3, because 36 times 3 is 108. So we know that x is equal to, square root of 36 is 6 times the square root of 3. So this is equal to 6 times the square root of 3. Alright, so let's look. We've got x is 6. This side is x times the square root of 3. And this side is 6 times 2. Okay, so that means that for any 30, 60, 90 triangle, so 30, 60, 90 triangle, okay, so here's my 60, 30, okay, here's how it goes. This side is equal to x, the short leg. The hypotenuse is equal to 2x. And the long leg is equal to x times the square root of 3. Okay, so short equals x. Long equals x times the square root of 3. And hypotenuse equals 2 times x. Okay, now this is just a brief overview. I'm going to go ahead and put a note here on the last slide so you can copy it down if you need to. But we will do more practice in class with working backwards. These are just the basics. Okay, so let's do this. We've got two things that we learned. we did 30, 60, we did 45, 45, 90, we did 30, 30, 60, 90. Okay, so pictures. This is what a picture would look like. These are congruent. This is x, this is x, this is x times the square root of 2. These are the things you need to memorize. Okay, so 30, 60, 90. So this is 60. That's 30. Okay, so this picture is x, 2x, and x times the square root of 3. Okay, so if we write it like this, that means that leg is equal to x, hypotenuse is equal to x times the square root of 2, and on 30, 60, 90, short leg is equal to x, long leg is equal to x times the square root of 3, and hypotenuse is equal to 2x. Alright, well, I hope I didn't go too fast. I feel like I might have gone a little fast. But this is just for your reference, and we will work in class. And you guys just get ready to work hard. Alright, I will see you tomorrow in class. Bye-bye.